Hello everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire and today we've got Abdullah who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation of that. So let me now hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready, Abdullah.
Hello everyone, my name is Abdullah. I'm mechatronics engineering graduate from Karabük University in Turkey. Today I'll be doing my presentation about the Linux basics. So do you want me to connect to the real physical robot?
Yes, please.
Right now?
Yes.
Okay. Okay, now we have the robot. First of all, I should start the robot interference. So to do that, I already prepared some codes to use. First of all, I'm gonna go to the file, to the directory, and after that, I'm just gonna hit this to run the interference. Here we should wait like 5 seconds. After that, I'm gonna launch the obstacle avoider file that I prepared myself. So as you can see here, it detects the front laser, and because it was blocked, it's changing its direction, turning right. After that, checks again the front lasers if there is a space to move. So my threshold was 0.600. So it's looking for 0.600 to move forward.
Why
and
did
as you can see here,
such a big threshold? Did it crash at some
What?
point?
What?
Why did you use a very high threshold like that?
So in the simulation, I think there is difference between the simulation and the real robot. In the simulation, 600 was good, and I didn't change that actually for the physical robot.
Okay.
Yeah, so we have the statistics as well.
But right now it gets awfully close to the wall. It doesn't look like it's leaving 0.6 meters in front of itself.
So in the obstacle avoider, down, like when it moved forward, it set the velocity for a specific velocity and sleep for 0.2 seconds. So that's what it does. So after doing that, it's go back and check for the front laser. Again.
And did you also notice that it crashed into the wall the second time?
I'm sorry, I didn't get it.
Oh, so on the top right corner, it crashed into the wall there. I'm not quite sure if it's so close, but it looked like a collision to me.
So I tried to not like go so complex on the code itself.
Yeah, you can also have a look at that as well. So
yeah, so I get the front laser or front distance. After getting the front distance, it check if it's blocked or not. If it's blocked, it stop immediately. But I think when it doesn't detect a near object, and when go forward like for 0.2 seconds, here like I should like work on that more. Well, I try to keep it simple this for this course.
Yeah, it doesn't look like it's following the heuristic that you gave it to stop every 0.3 every 0.6 of a meter before an obstacle, right? So I think something is going wrong there. It's either when you set the values, the heuristic doesn't get checked to see if the robot has reached within the 0.6 meters you gave it to be how as close as it can get to the wall, right? And yeah, look at that as well. So you can see right now on the left side, right, top left,
Yes.
it had to collide first before stopping, right? This is what I was talking about.
Yeah. So as I said, it doesn't check the distance like every time. It's just checked it once, and if it's so close to the wall, try to turn left or right. And if it's not too close, like it's above the thresholds, then it just move forward for like 0.2 seconds, as I said.
Okay, so pull that script up and let's look through it statement by statement.
Okay. So this is a bash document, and first of all, we source the library.
All right.
Yes.
Let's focus on the obstacle avoidance logic. That's what I want to see what's going on there.
Okay, so here, right, the main.
Yeah.
Okay, so I have the threshold 0.6 meters. First of all, it gets the front distance after get from the get front function or method. After get the distance, it set the velocity for 0 for safety. Then it checked each front distance. Like we get a list here for each element of the list. Check if it's under the threshold. If one of the distance is above is under the threshold, then the is back return as 1, as true.
Okay.
When it return as true, then we have an obstacle in front of us. So we should stop and look for other direction, like turn the left or turn right. So after getting that there is a closed object to us, then we stop the vehicle again, and after stop the vehicle, like we echo blocked for the terminal, then we check the sides, the left and right side. We get the distance for the left and right, and check if the left side is smaller, it's like closer from the right side. So we have a bigger an empty space on the right side more than the left space, then we're gonna turn right.
Okay.
Vice versa. Yeah. So to turn right, we just like set the angular velocity to 5. To turn left, we set 5. To turn right, we set to -5. And we turn for like 0.1 second, and after that we stop the vehicle again. So this, if there is an object detected. If there is no object detected, like is block equals 0, then the path is clear and it's just gonna move forward with the velocity of 2 for 0.2 seconds.
Okay, so this is the whole of the obstacle avoidance logic. Okay.
Yeah. So I try to keep it simple and basic. Like, as you guys mentioned, the notebook, like, don't go crazy on this one. That's why I use this method, because it's easy, you know?
Yeah, well, it makes sense, right? It makes sense. The only bit that I have a problem with is the fact that we are not really checking the condition that are we close to the obstacle in any way. When we set the velocities to some value that's not 0, I don't see anywhere where that is happening. I don't see where we are putting a guard measure in place to say, okay, we can go forward at this particular speed, but how do we know that we have not collided? Like, how do we know that we must stop now, right? That's my biggest issue. And I'm guessing from this, from what I've just explained, that's where the stop after collision effect is coming from. So as simple as we would have wanted it to make to be, it doesn't prove to be sufficient at the moment. But
yeah,
let's look at the other scripts that we had to develop, and then we can maybe come back to this one a bit after.
You mean the robot statistics?
Yes.
Yeah, so basically just to get the X position and Y position, the odometry of it, and that's it actually.
Okay.
I didn't,
All right. So
I
you
didn't
were getting as little
here.
values as you could. Okay. It's
Yeah.
it's a good platform. It works, which is it works to some extent, right? So I have to put that percentage to what extent does it work. But yeah, all right. Anything else that you wanna show us, Abdullah?
Uh, Actually, no, that's it for me.
Okay, all right. No worries.
We can run the same script on the simulation if you want.
The statistics script. Yeah, you can run it so we can see it working. Just put it in the third terminal.
Uh, you mean the okay? 1 second. And so it gives us the x and y position.
Okay.
Each 0.5 second.
Okay. All right. The is I'm guessing the robot is not moving right now. Oh, it's moving because it's changing.
How should I check it? Oh yeah, it's more than one.
All right. Let's. All right. All right.
It's spinning. I guess it got stuck here, like it turning left and right.
Yeah. Yeah. All right. You can stop execution of all the scripts, and then we'll wrap it up here. Okay. Alright everyone, this was Abdullah's presentation, and I would like to encourage all those of you who would like to try the courses that we offer certification on to do so, and you can also come and showcase your work and try to get us to understand how you did the work and why you think your method is better.